Hi everyone, today we're going to continue our analysis on refrigeration cycles. So let's get started. You find that the refrigerator is running R134A, and you assume that the refrigerator is running an ideal vapor compression cycle where state 1 is saturated vapor. So we can start listing our state point. So state 1, where it's saturated vapor, that means our quality is 1. At T low. So T low from the previous video, it's 0 degrees Celsius. And for part A, the compressor compresses the refrigerant isentropically, important stuff, to a pressure. So if we know it's going to compress the liquid isentropically, that means S2 is equal to S1. And then the pressure is 0.6 megapascal, so it compresses the liquid to P2 equals to 0.6 megapascal. What's the phase and temperature of the refrigerant at state 2? Draw this process on a TS diagram. Okay, so we're going to use the entropy data to find out the phase and temperature. So we know that the quality at state 1 is 1 and the temperature is 0 degrees Celsius. So if we go to table A.1, at temperature equals to 0 degrees Celsius, S1 is equal to Sg because it's vapor, and that is 1.7271 kilojoule per kgK. And since S2 is equal to S1, we can directly write out the entropy at state 2 as well, which is 1.7271 kilojoule per kgK. So now we're going to compare this S2 to Sg, which is the entropy at the vapor phase at pressure equals to 0.6 megapascal. If S2 is bigger than Sg, then that's a vapor. If it's in between Sg and Sf, then that's a mixture. If it's smaller than Sf, then that's a liquid. So let's go to table A.2. Yeah, so this value is from table A.1. So now we're looking at A.2 at pressure equals to 0.6 megapascal, then Sg is found to be 1.718 kilojoule per kgK. Okay, and then since S2 is bigger than Sg, so these two numbers, if we compare these two, S2 is bigger than the Sg, we can conclude that it is in a vapor phase. Okay? And now we need to find the temperature at state 2. So if we go to table A.3K, that's when the pressure is equal to 0.6 megapascal. Ideally, we can just read off the table, find the entropy value, and find the corresponding temperature. However, it's usually not right at the entropy value. That's when we need to interpolate. So if you go to table A.3K, and that's at temperature T saturation is equal to 21.572 degrees Celsius. Okay, so that's the temperature for saturation. And then on your table, you'll have something like this. So you have the temperature, and you also have the entropy. Our goal is to match the entropy with this S2 and find the corresponding temperature. So we have the T saturation, so 1, 2, 3. So we have the T saturation, T1 is 21.572, and we also have T3, which is 30. So this is your first row, and so this is your first row, and this is your second row, and we also have all these entropy values: 1.7175 and 1.7455. So we have 1.7271 as our S2 here. So we really want to find this T2 right here. So let's interpolate. So T2 is just S2 minus S1 over S3 minus S1 times T3 minus T1 plus T1. And that gives us 24.46 degrees Celsius for T2. Okay? In the next video, we're going to continue our discussion and finish part B. Thank you.